What's up, everybody? So in this video, we're going to be looking at how to do different function operations. So we're going to look at how to add, subtract, multiply, and divide functions. So here's really just kind of basically what it looks like, and then some different examples. This is really easy, guys. This isn't something you want to overthink. You're literally just taking the functions and adding them, subtracting them, multiplying, dividing them. There's not a whole lot of trick to this. So if we look at a few examples here, I can show you if we've got this function f of x and g of x, and let's say we want to add them together, then we can easily do that. So we just take 3 square root of x and negative 10 square root of x, add them together, and we'll get negative 7 square root of x. So it's really that easy, guys. It's 3 square root of x plus negative 10 square root of x is just negative 7 square root of x. As far as the domain goes, we can look at the possible x values as far as what's inside that radical. You can also load this up on Desmos or another graphing calculator to see what the domain is. But this one doesn't look like we can have any negative x's. So I'm thinking for the domain on this one, x has to be greater than or equal to 0. Just because we don't want square roots of negatives. So domain, we're going to say is x has to be greater than or equal to 0. And then it says to evaluate when x equals 4. So if we stuck a 4 in there, let's do that right here. Negative 7 times square root of 4. Square root of 4 is 2, and 2 times negative 7 is negative 14. So when x equals 4, f plus g of x is negative 14. All right, subtracting is just as easy. We're going to take this function right here, f of x, and we're going to subtract this function right here. Okay, so we could take 3. Now, for adding and subtracting, we have to do like terms. So we could take 3x cubed and subtract 1x cubed to get 2x cubed. We could take negative 2x squared, subtract negative 3x squared to get 1x squared, or just x squared. We could do let's see. We don't have an x over here, but we do here. So we're going to say 0 is the x over here. So 0 minus 4, 0x minus 4x is negative 4x. Be careful on those, guys. If you don't have 1 in the first one, it's a 0. If you don't have 1 in the second one, it's a 0. So we didn't have an x over here, so we counted that as a 0x. So 0x minus 4x is negative 4x. And then finally, our constants 5 minus negative 2 is a positive 7. So here you go. This is your new f minus g of x, this new function where we subtracted the first function and minus the second function. All right, as far as domain goes, I'm thinking that it's going to be all real numbers. Again, guys, you can always use Desmos to justify that. So 2x cubed plus x squared, or any graphing calculator, plus 7. And we can see what our function is going to look like here. So we can see it does go to the right and to the left forever, very slowly, but it does. It doesn't end anywhere, so all real numbers is going to be our domain. Then evaluate when it's negative 2. We'll save a little bit of time in this video, but all you would do is just take that negative 2, substitute it into x, and evaluate what your answer would be. You could do this on a graphing calculator or whatever you want. All right, multiplying two functions. So let's say we're taking x squared, f of x, and we're multiplying by square root of x. What would that function be? Well, what we want to do here is we want to write it in exponent form. So we're going to write this as x squared. And remember, when we have something as written as a radical, we can write it in exponent form. So we have an imaginary 1 up here as an exponent because we don't have an exponent. And then we have a 2 right here, an imaginary 2 for square roots. So we can write this as x to the 1/2. X to the 1/2. All right. So we have x squared times x to the 1/2. Remember, when you are multiplying two different bases that are the same, or I guess two of the same bases, but they have different exponents, you can add the exponents together. So 2 plus 1/2 is going to be, I think, 5/2. So we can write this as x to the 5/2. Okay, or we could write it as square root of x to the 5th. All right, so either way, you can write it either way, but that would be that function. And then we have to see what would the domain be. And again, it looks like since we have the square root here, that x has to be greater than or equal to 0. But we could justify that with our Desmos here. So if we typed in x to the 5/2 and took a look at this, we could see, aha, x starts at 0 and it moves to the right. So it has to be greater than or equal to 0. You can't have any negative x's because, again, the x is underneath that square root. All right, let's look at one more example, and then I'm going to show you how to do this on a calculator. So with dividing two functions, exactly the same idea. We're going to take this 6x, and we're going to divide by x to the 3/4. Right? So we could do the constants first. 6 divided by 1 is just 6. And then with the x's, remember there's an imaginary 1 here. We can subtract the exponents, so we'll get 1 minus 3/4 is 1/4. So remember, when we're dividing bases with different exponents, we can subtract the exponents. So we get 6 to the 1/4. Or we could rewrite this as 6 times the 4th root of x. 6 times the 4th root of x. And then as far as domain goes, again, I'm thinking that it's going to be x has to be greater than or equal to 0 because of this root here. All right. Okay, last but not least, let me show you how to do this on the calculator. So, and I'm going to try to show you with my little webcam here. So, we're going to see if we can make my face just a little bit bigger so that y'all can see what I'm doing. But you can enter in your y functions on your calculator. So, if you look at your calculator here, you want to press the y equals, and then on y1 and y2, you want to enter in what your functions are. So, like, for example, I've got the function 5x cubed and 20x to the 1/4 loaded into my calculator. This isn't matching with what's on screen for the example 5, but you can use, we'll just use this as an example. So I've got those functions loaded in. If you're wondering where to put the x, how to type in the x, you can do that with this button right here. So it says x, t, theta, n. So you can do that with that button to put in your x's. Anyway, once you get your functions loaded in, again, using the y equals right there, y equals right there. Once you do that, you can press second mode. So second mode, all right? And then you can type in your functions using this, like if we want to access the functions. Let's say we want to add two functions together, and says when x equals 2 on our directions back there. So let's say we want to type that into our calculator. We want to add two functions, y1 and y2, using the calculator, and evaluate it at x equals 2. So we can type it in like this. We can do alpha, which is right here, alpha, and then let me make sure I get it right. Alpha trace, okay? Trace is right here. Alpha trace, and it'll bring up all your little y's, y1, y2, y2, y3, whatever. Okay, so let's say you want to do y1, so I'm going to press enter, y1, and then we want to take y1 when x is 2. So in parentheses, we'll do 2. So we're typing in y1 parentheses 2, so that's going to evaluate the function at 2. And then we want to add to it, let's say we want to add the functions, add to it y2. So again, do second trace, okay? Nope, that wasn't it. It's alpha trace, my bad. Alpha trace, okay? And then we want to go down to y2, press enter, and then in parentheses, we'll put 2 again. So we're saying that we want to take y1 and add to it y2, both evaluated at 2, press enter, and it'll give us an approximation of what that function is equal to at that point. Okay, you can do this with addition, subtraction, multiplication, division. All you're going to change is just that little plus in the middle to suit whatever operation you're trying to do. But that's how you can do this on your calculator, guys. Guess let me make my face smaller again. All right, but that's how you do that, guys. So if you have any questions, let me know. And thanks for watching, and I guess I'll see y'all in the next video. Y'all take it easy.